Hi, welcome back. We're here today at Boulder's Signal Shop with transportation engineer Joe Paulson, who takes care of Boulder's traffic signals and street lighting. So Joe, what do you and your coworkers do here at the Signal Shop?
I work with a team of 3 signal technicians, and we're responsible for the design, construction, operation, maintenance, and repair of Boulder's 145 traffic signals, as well as a variety of other traffic control devices in the city, including the flashing sign pedestrian crossings, school zone flashing beacons, radar speed display signs, underpass lighting systems, and so on. Basically, if it involves traffic in Boulder and electricity flows through it, it's probably our responsibility. My role in this team is to determine what I want a traffic control device to do, and it's up to the hardworking team of signal technicians to figure out how to get it done and perform the magic that makes it real. The signal technicians are actually on call 24 hours a day, 7 days a week, because of the critical nature of traffic signals. So if an emergency happens, such as an accident causing a signal to be knocked down in the middle of a snowstorm, the signal technicians will respond, and they will be out there night and day until it's back in working order to serve the public.
Wow, that sounds like a very critical, important team. You mentioned the traffic signals. I've always kind of wondered how the intersection, the lights know that there's a vehicle there. Could you tell us a little about vehicle detection, how that works?
Certainly. We use a variety of vehicle detection systems to inform the traffic signal controller about the presence of traffic. For example, whether or not there is a vehicle in a left turn lane, so we know whether or not to turn on the green arrow for that vehicle or not. Historically, most of that has been done with induction loop systems, which are coils of wire embedded in the pavement surface, and those have a current flowing through them. They basically act as metal detectors. One challenge with those is every time you have a problem with your pavement, or maybe you're replacing it with an overlay, you have to destroy the loops and replace them, so it's an ongoing expense. So for primarily that reason, some years ago, we started to transition into video detection technology. So you may have wondered what all those cameras are up on the signal mast arms. That is simply a replacement detection system to, again, inform the signal controller about the presence of traffic at that location. And now we're currently branching into some other emerging technologies such as microwave radar.
So does it work the same way for bicycles?
Very good question. Yes, because we are trying to use cyclists as a major component of our transportation system, we need to serve them just as effectively as we serve vehicles. So therefore, we endeavor to provide the same service. However, because bicycles are a little more difficult to detect, it's very important that they be in the appropriate position. To help them do that, if a cyclist approaches a signal, and if you look at the pavement marking for the stop bar where you're supposed to stop at the signal, you will see a bicycle symbol and a pair of white lines for you to line your wheels up on. And if you stop there, positioned over that bicycle symbol, you are positioned over the most sensitive part of the detection system, and it will detect you reliably on your bicycle.
Oh, that's great. And you know, I've noticed, I think most of us have, a lot of different kinds of intersection lights happening these days. What's new in the world of traffic signalization?
One of the newest things in signals is the flashing yellow arrow display for left turn signals. And that flashing yellow arrow symbol replaces the circular green ball indication that has historically been used to inform drivers that they're allowed to turn left, but at that time they need to yield to any opposing traffic. The federal government for several years did a study of different left turn indications, and the results found that this should be a more effective system. So they moved on to field trials in locations throughout the nation, including the city of Boulder. And the consistent results from those field trials were that left turn accidents actually were reduced using that flashing yellow arrow display. So recently the federal government adopted that as a new standard display for traffic signals. So you'll begin to see more and more of them, not only in Boulder, but throughout Colorado and the rest of the United States.
You also mentioned that your division takes care of Boulder's streetlights. Could you tell us a little bit more about that?
Yes, that's correct. There are more than 4,600 streetlights throughout the city of Boulder. The primary provider of the street lighting service for us is actually Xcel Energy. They operate and maintain most of the streetlights with the city of Boulder as the customer. However, the city is interested in moving into some emerging technologies for lighting systems that can be more energy efficient as well as more effective for visibility. And so we have started to install some of our own street lighting systems. One example is up on 28th Street in the vicinity of Iris, where we have a system of induction streetlights, which provide very clean white light that helps provide better visibility.
So Joe, I see all these flashing lights and equipment all behind you. Could you explain a little bit about what this stuff is?
You bet. This is actually a traffic signal controller cabinet. If you were to go out to any traffic signal in Boulder and look around on the corners, on one of the corners you are going to see one of these metal boxes. And if you open it up, you find this array of electronics inside. So this is actually the traffic signal controller. This is the brains of the system. This is what we program to tell the signal how we want it to operate. And then the rest of the electronic equipment is basically providing the electricity out to operate the signals themselves. One feature in many of our newer cabinets, including this one, is this array of batteries down here at the bottom. So that provides a backup power system so that if the energy fails at the traffic signal, the signals can continue to operate until power is restored.
And how about this board up here?
That is called a test display, and that is acting just like a signalized intersection to take the output from the signal controller and display what it would do if you actually hooked it up to an intersection in the field. This allows us to test operations and try new things before we actually put them out in the streets.
Would you say that Boulder presents any unique challenges to coordinated traffic signals than other cities?
Yes, there are a number of challenges to providing good two-way traffic flow progressing through signals in Boulder. One of those is that Boulder does not have a lot of one-way streets. Almost all of our streets are two-way, which therefore means you have to provide the signal progression not just in one direction, but in two. And that is a much more complex problem that's much more difficult to achieve than when you're simply trying to provide one-way flow, such as Spear Boulevard in Denver. And that is complicated by the fact that when Boulder's street system was laid out more than 100 years ago now, before traffic signals even were invented, the folks doing the street design weren't thinking about the future need for signal spacing, so they did not lay the streets out in a uniform pattern. And one of the fundamental requirements to be able to provide two-way flow on traffic signal networks is that the signal spacing be uniform. Because we don't have uniform signal spacing, it's actually impossible to provide that nonstop flow that everybody would like. That challenge, of course, is increased when you have the intersection of two major streets, such as 28th and Arapahoe. You're actually trying to provide traffic flow to not just two directions, but four directions of travel, all of which would prefer not to stop. And in addition to our vehicular customers, we're also trying to provide adequate service to the needs and desires of pedestrians and cyclists here in Boulder, and that, of course, adds to the complexity of the challenge.
Oh, sounds like quite a difficult job. Thank you for being here with us today,
Thank
Joe.
you for coming down to the Signal Shop.
We've been speaking with transportation engineer Joe Paulson here at the Signal Shop in Boulder. And if you'd like more information about traffic signals, you can go to the city's website at bouldercolorado.gov and click on the A to Z link at the top, go to T for transportation. You may also call with any questions and concerns to the Signals Information Line at 303-441-4056. And they will mail you one of these handy brochures with all sorts of information about the traffic signals around Boulder. Thanks for being with us, and we'll be right back.